So that technology, this arrangement is called Smart Scale. And what really makes it smart, what differentiates it from just being the adoption of scalers is this word smart. This is the key thing that, you know, you're going to get into a lot of tactical discussions, you're going to get into a lot of debate with different dealers talking about different manufacturers' use of scaling technology. This is truly a smart scale, and what we mean by smart scale is we actually have, our switcher has a relationship with every single monitor. Before we route anything to it, the very first thing we do is we read its EDID table. And just, are you guys familiar with EDID? Have you seen what an EDID table looks like?
Heard it mentioned, maybe.
Okay. Okay. So just to kind of equip you with what it really, what we're really talking about here. Every single display, every endpoint, anything where you can put video into something, that endpoint has what's called this EDID table. And this EDID basically has a ton of bytes of information, right? And each one of these represents some display characteristic, okay? So if I know all this information about a monitor, that means I can make some smart choices about how I deliver content to it. If we look at what some of that information is, you're talking about 21 different actual resolution qualities, if you will. So we understand all of these video things about the monitor. Most of the time when we're designing, in the old days when we design AV systems, we would think about only horizontal and vertical. We'd think about 1920 by 1200, 1024/7, 68. That's all we really cared about. But in the digital generation, we have to know about every single one of these things. You know, a single mismatch of something could result in the absence of an image, just a complete blank screen. So what makes Smart Scale smart is, I'll back up. If we took just a subset of those 21 values of information, we just took the most dominant ones, the most highest value, the most variable things we could, and we just multiplied those out to find out how many different, you know, permutations of that signal it could be, or how many different things, how many different versions of a signal we could create. We basically come up with that many possible combinations. I don't even know how to pronounce that number. I don't know what that is, but that's just basically, you know, multiplying all of those out to come up with all the different combos, right?
Looks like the national debt clock.
That's right. That's exactly right. So this isn't realistic, right? This means that there's a potential that one of those combinations is 1 pixel of information 10 miles long. There's no display that actually does that, but it just makes the point that there are that many possibilities, and the more tablets and the more random devices that get built and brought into the marketplace, there's going to be more things that we didn't anticipate would be, you know, common resolutions. So even if you took like 1 in a million of those as being realistic options, you're still talking about 311 quintillion, or 311 quintillion combinations. That means that the scaling chip that we employ in here, and we employ the scaling chip on every single output, that chip is one that we built back in 2005 for one of our touch panel interface products. We built it, we're in full control of it, and that's how we're able to just take all that information. Engineers here have just done an amazing job at just manipulating every aspect of a signal and mapping it to whatever we want to map it to. So anytime I connect this display to my switcher, I read what it can do, and I make sure that whatever the best resolution that a source can bring into me, I'll take that and I'll map it to all the display's best characteristics. That's how, even though I've got a 1080p video showing up on a 1080p monitor, I can still see the best version of 1080p I can on this itty bitty little confidence monitor. Right? This is huge. And from a customer value standpoint, think about this. If I don't have Smart Scale on every single output, what does that really mean? It means at some point there's a possibility that I could go to route to source and it wouldn't be able to be shown on that destination. With Smart Scale on every single output, it doesn't matter what I've put in, the system's going to make sure that the displays all can project some version of that image at its best capability. That story I was telling you about right before we turned on the camera of this monitor failing right before one of our big customer events, we replaced it with a different model. We didn't have to go in and recommission the system. We pulled this monitor off. we put a different monitor on that had a different refresh rate. So they were both 1080p monitors, but the second monitor we put up was a 24 frame monitor. I didn't have to go recommission anything. The minute I attached it to this smart scale technology, it read what this thing needed and it gave it the right image. So customer value, you know, total cost of ownership. If I'm going to own this technology for 10 years, minimally 10 years, I know that my displays are probably not going to last that long. I know I'm going to be replacing things. And do I want to invest in technology where I can just make the swap out, or do I want to invest in technology where I'd have to go in, pay somebody to come back in with proprietary software and recommission the system and make it work for, you know, whatever the changes that I've made to my environment. Makes sense, right? So this Smart Scale and Instigate Pro, this is ubiquitous. Anytime you see the word Enova, it means that we have that scaling relationship with every single output. Whether that output is local to this box or whether the output is through one of our receivers. Whatever actually attaches to the monitor, that's where that scaling technology lives. So when we go downstairs next and we talk to Jeff Birch and we talk about the DVX, it's all the same stuff. Now really the only difference between the DVX and DGX then is size and a few other different audio capabilities. So let's take a look at just DGX in general.
The Smart Scale.
I'm sorry, Jim?
Is it on a reboot or is it one time
It's,
and then it remembers?
it's pretty much when it connects. So when it connects, that's when it reads the EDID table and it makes those choices. What's cool about the Smart Scale is I can leave it in smart mode. I can say just auto detect, and when I do that auto detect, it's upon connection. If my display lost power, when it powers back up, anytime a display powers up, it pushes out its EDID. If there's a connection point there. So anytime that's going to push EDID, we're going to go, oh, something's different. We're going to just recalculate that algorithm and go. Now, we could leave it in auto mode. We could go ahead and manually we could manually configure the scaler if there was one real specific resolution that, for whatever reason, maybe we were going into a broadcast feed. We just wanted to ensure that it was always outputting one specific thing for that recording device that was on the endpoint there. We could manually set it, or we could just bypass the scaler altogether. You know, the scaler right now, the scaler doesn't have any, we haven't seen any 4K content yet, right? So the scaling is kind of the limitation in passing 4K content. We don't know what it's all going to look like. So if we wanted to pass, you know, 2K or 4K through the system, we would just bypass the scaler, right? Because it's the scaler's not going to know what to do with it. But for everything up to a certain point, and later on, it's just basically you know, it'll be firmware to basically change what it can do. You know, if there may be a different scaling chip at some point, we'd change the write-up on it. So that basically just kind of shows one more example of what we mean by Smart Scale on every output. Doesn't matter if it's local or remote, we make sure that every destination gets what it should have.